Hi everyone, welcome to MathSpellBook. I'm your host Peter, and basically we're going to get into we're going to do a little something different. So instead of just doing proofs, we're going to do a little bit of physics problems in addition to a little bit of proof writing. So I thought I would just go over maybe an hour of doing some physics problems and maybe an hour of just basically doing some proof writing that Sasha assigned for us. So it's funny because I actually found an old homework sheet that I got, that basically I had for when I tried to do physics, when I was actually trying to do engineering. And one of my coworkers slash classmates, funny because he was in the same class with me, he went off to continue on doing engineering, so he sent me some of the problems assigned by the professor in the Physics 2 course. So I thought I would actually do some of those problems here. I did some of them this morning, so I thought I would just finish off. So we're literally on the first homework. I think I did around 1, 2, 3, 4, 5, 6, 7, around 7 problems this morning. And the first chapter we still have 1, 2, 3, 3 problems left. And then it seems the professor also assigned 4 problems from chapter 6. So I do have the book on my web browser, so we can actually look at that. Okay, so I did try to do some of this morning, this problem 69 here. So 69, so first part is how many parsecs to what they listed in the problem. An AU, 1 AU is equal to 10 to the 11th meters. And according to them, 1 parsec seen in the astronomy book I have, 1 parsec is equal to 1 AU over 1 arc second. And an arc second is take a glance at the solution a bit, because according to them, 1 AU times 1 parsecs there are. And I think the problem, they want us to basically, so this is a degree, so I think they want us to like we have like a distance. Because we have like the AUs. We have like 1 AU, that distance. So let's see. This is like of a degree, so we're going to have to annihilate the degrees. So according to this, I think this is how it's supposed to. Times 60 degrees, because it's in radians, so that way it will give us the unit. It will not give us a unit, so we can annihilate the degrees. So let's see what this turns out to be. solution from what I saw is that they did this and then they multiply second. And I know they did this conversion here because they want to get rid of the degrees, because I think arcsecond is part of degrees. Now, I think they probably did this just to make it easier, maybe, the calculations, because this is the degree. So we already know what AU's equals. Doesn't look right. Yeah, because the way I saw the solution, that the way they wrote it was kind of like strange. Because we do have AUs, we're just trying to figure out what the parsecs are. It's like how many parsecs there are in an astronomical unit. According to so when I check on Quizlet, like basically we like now I kind of see like what they were getting at here. So it just looks strange because usually like I'm so not used to seeing like you know, you just multiply the units with the number. Parsecs. I guess they did it just to basically get rid of the degrees. I think that's the reason why they wrote it that way. So how many meters are in a parsec? Well, let's see. I think we could probably work backwards because an AU was like 1.496. So maybe, because that's how many parsecs there are in a astronomical unit. Meters is equal to 1 AU. So if that's how many parsecs there are in AU, that means it's probably going to be a lot less parsecs in like in meters. So let's just double check on what we know what the question is asking. So how many meters are in a parsec? Okay, so we have to so maybe we can do 1 divided by 1 divided by an AU times the arc second. So I think in this case we're going to be doing the same thing but in reverse. Because like 1 over an AU is basically well, not 1 over an AU. I think we'll call this. We'll call this value phi, make it easier, because we want that of an AU, not like 1 AU, but that much of an AU. I'm just trying to simplify my thoughts here. So like we have that, and then we're gonna have the same process. The only difference is that we'll have 1 parsec, so that's going to be left alone, but we're still going to have then we're going to have to divide it on the other side, so then 1 parsec is going to be equal to write it as x. Make the algebra a little bit easier on the eyes. I know the notation looks weird, but it's just easier for me to actually see it. Because I think this is what we need to do here. Okay, now for the fun part. So 1 over times does that work though? Because the one thing that's iffy is that the reason why I didn't put 1 over an AU is because I don't want the meters to get in the way, because that's the one thing I don't want. So I just wanted to write this value, because 1 over that will be literally 1 meter, which is like hopefully my thinking is right. If it's not, then I'm gonna have to look back on that. But they never said physics is easy. No. Yep, I didn't get it right. Oh my goodness. I thought I was trying to be clever, but it didn't turn out that way. But, you know, I post my successes and my failures in each one of my VODs, each one of my YouTube videos / Twitch streams. But of course, like in physics, they basically say the more you learn, the stupider you feel. I thought I was being clever with that one, but unfortunately, no. That's not how it works. Okay. Because I think that's the thing about physics problems, is that you feel like you know how to do something, but then apparently it just like, you realize that, oh, no, that's not the right approach here. Because I think with like physics, like sometimes you think that there's a mathematical trick to it, and then like you realize that, oh wait, hold on, I wasn't thinking about it in this way. Because apparently, according to what I was doing, because they did what I did before when I was trying to figure out the parsecs. Because basically what they want is that you divide 1 AU from this mess. Apparently, that's how many meters. So a parsec is basically much further away than the sun, which is really interesting. Yeah, this one was pretty tricky. I had to figure out what a parsec was, and then I had to figure out exactly like how to actually do it. That's the one thing. Because I knew it had to basically, we had to like take away from like 1 unit to basically get the meters. Okay. Let's see, you spot a plane that is, let's just draw this, kilometer north, just the y-axis. Actually, let's write this in. Let's erase this. And we'll write east here. So the vector we're dealing with is y plus kilometers east. Oh, whoops. No, it should be the other way around. far from you is the plane? What angle from due north in the horizontal plane are you looking? Determine the plane's position from your location in terms of the unit vectors. Let's see, let I be towards the east direction, towards the north, and vertically upward. What elevation angle above the horizontal plane of the Earth is the plane? Okay, so we got a lot of questions in this one. No wonder it's like number 3. I mean, like, it has 3 dots. 3 dots is usually like the most challenging. So you spot a plane, so we wrote it in this way. Let's just put a small p there for the position of the plane. How far are you? How far is the plane? How far from you is the plane? So I guess we're gonna have to take the distance here. So the magnitude x. Let's see. Oh, they're all kilometers. So we're gonna have to do some simplification, or conversion, I should say. The significant figures here. So from us, it's like around 7.8 meters. From due north in the horizontal plane are you looking? So I'm guessing from here, so let's pretend that the plane is like right here. I know that's not a really good drawing of a plane, but we'll deal with it. So we have to do this angle, because it's the due north here. So we'll just call that theta. So I think this vector is basically the one we have, meaning right here should be up to kilometers. Oh, wait, yeah, it's kilometers. We probably should invert this. I just remembered. So this is 5.8 kilometers. So that means 1 kilometer is 1,000 meters. We probably don't have to convert it, but I prefer to do it anyway, because that's how I usually remember because I just want to keep the units like perfectly sound. Okay, so for B, what is the angle? So there's two ways we can do it. I know it's not exactly here. It should be like right here, I think. It should be like that, actually. And this line should be kilometers there. Hey, Sascha. Thought I would work on some physics problems, so. What's the best part of your day so far, my friend? Okay, so for B, determine the angle. What is the angle from due north in the horizontal plane you are looking? So we have to do it from the plane itself, I think, not from with the z-axis, or do we? Meaning we have to rely on the first two here, so sine and then cosine. That should give us the theta we want here. We're working on some coding project for ocarina of times. Oh, okay. What exactly is that? Kilometers. So the angle we have here is 30. Well, actually, how many? Probably should make it two significant figures, because this is science after all. So 31 degrees. Maybe we should put like 0.0. Make it a little bit. Oh, Zelda. Okay, Zelda randomizer. Okay. So I think that's what we need for the horizontal. Determine the plane's position vector from your location in terms of unit vectors. Oh, okay. We already did that. Yeah, we already have that done. At what elevation above the horizontal plane of the Earth is the plane? Okay, so now we actually can use what we were thinking of before. So hopefully this is right. Let's see. So we have 5.8 kilometers. And so now I think we're gonna have to make another vector, which is like the one flat on the ground, because that's going to be our kind of our cosine there. Yeah, because then no, not cosine. What am I talking about? I think I'm so used to like seeing it in this format that I'm always labeling this cosine, sine, and like, you know, z, whatever it is. I don't know why I developed that habit. Maybe it's because of polar coordinates. I think that's how my thoughts like basically swirl around my brain. Okay, so we have the vector, we have the actual vector itself, which is this, and we have the magnitude of that vector. So from up here, we know that the height is 5 meters, so this is fine. Maybe we should do the sine. That might be easier. Because then we can do kilometers here, and then 5 kilometers from the vector itself. So 59. Maybe we should round it to 60, because we have 2 significant figures mainly. There we go. I mean, technically I kind of put 3 significant figures here, but hopefully those are the correct numbers. I feel like those are correct, because let's see here. To do the angle above the ground, because we have this and that has a magnitude of that, and then we have the height here, which is basically like above the horizontal. So that's what we got here, because that's what we need actually above the ground. We don't really need this part because it's sine, so basically it's just opposite. I mean, not yeah, it's like opposite over hypotenuse. So let me check and see if that is the answer we're looking for. So this is number, I think it's 79. It's either 79 or 76. 78. Okay, I was close. So 78 for 1. Oh, they didn't include the Z one. They didn't include the Z coordinate for the first part for A. Did they? Oh no, they did. Oh, okay, they did. I was like, what the heck? I guess they did it in parts. Like they basically did it for the X, Y, basically for the X and Y directions, and then they did the Z direction. They could have just. Okay, so I think we got that one correct, because it said 5.98, 5.79. So, oh, let's see. I did B wrong. Dang. Well, I haven't solved problems in a while, so it doesn't surprise me. apparently they switched these. That's the reason why I got these wrong. So let me think. So apparently they have 2.5 up here, 1.5 down here. So let me see. Gave them 59.1. Because, let's see, it's in this direction. That's 2. Why is that though? Because it says that 2.5 east, which means it's... Oh, wait a minute. Oh, I got my coordinates like mixed up. Because this is supposed to be X and this is supposed to be Y, right? Yeah, I think that's how it's supposed to be. But why is it that it's like 2.5 and 9 here? Because the height here, and then from 2... I'm guessing I basically did the measurement, but this would be X over Y. I always thought it was Y over X. Because sine... I know I got C right because that's how we structure it. Now, well, yeah, we got like D right. That's a relief. The one thing is that what do they have in the book for the answer for B? This is, oh no, this is 78, which means it's not going to be in the book. But why is it this? Because I would think for measuring this side, like if I'm supposed to be at the 0 coordinate, I would think that 2.5 would be at the bottom and 1.5 would be on top, because that's basically the north. It's like the x-axis, the y-axis over the x-axis. Yeah, that's weird. Did they do this part wrong in the solution that I looked up? Huh. That's the one thing about like textbooks. Sometimes it's like, did they do it wrong, or like did I get it wrong? More likely I got it wrong, but at the same time I'm like, what is it that I'm mixing up here? I wonder, does Quizlet have a web browser? Like, does it have a, like, internet, like, website? Or is it just an app? 'Cause I want to see if I can access stuff here. Okay, yeah, oh, I didn't know I can actually access this. Okay, so let me just bring what I'm looking at down here so you guys can see it. Because maybe looking at the diagram will basically make it easier. I'm like wondering, why is it that they have like 50? Because the way I measure, because like right here in this problem, we need to find out the angle due to north when a person looking at the plane as seen in the sketch from the problem. And according to this, they have this type of setup. Let's see, therefore the person is looking from east to north. So, oops. So it has to be in this direction, from east to north. Oh, okay, so it's theta here. So that means we have to go the opposite direction. That's probably why. Yeah, because like theta's right here. So that means we have to be like on here and then basically measure that. Okay, that's probably why. Yeah, it's kind of hard because like it's not very clear on like which angle you're going from. Let me see what the question says, because maybe I didn't read the question correctly. Let's see here. From what angle due north in the horizontal plane are you looking at? So from the in the horizontal plane. So that means they assume that we're just looking straight here and then like looking at this angle here. That's very interesting. And I'm guessing alpha is supposed to be from like looking at from the z direction. Which is how we got this right. mean, that makes sense because maybe I think it's because like I didn't read the question correctly. But of course the question is a little bit more, I don't want to say cryptic. Because it says what angle from due north. And I think that's the thing I missed right here. So if it's like if what is the angle from due east, I probably would have been correct because it's from like, but this one is from like the northern part, so it has to be from like the y-axis to the x-axis, or the like to the vector itself actually. Well, I guess we got some of these problems right, so no use mulling over those. Okay, so at least we did some physics today. So let's review what we learned. So in this one, we just know that if we're doing with astronomical units like astrophysics, like parsecs and astronomical units, we're gonna have to like convert so like arc seconds is like 1/36 of a degree, so we have to know that we have to convert it, and to get the meters we do this type of procedure. In this one we just have to keep an eye on our angles, because I think that's the thing that we have to be aware of, because I mean we got like this one we didn't really get correct because we were struggling through, like this one I kind of remembered the routine because I saw the solution before and I just didn't understand it, but now I kind of understand why it's like this. But for this one, I mean this one I kind of like, for letter C I kind of like did it already because I had an idea of what it was aiming for. A, that one was pretty simple. For B, I just basically misread this one, like we managed to get it, and it's pretty like simple for this one. I mean, it was simple for me to visualize, so yeah. So I think that's pretty good. So we got like probably like probably got like 70% out of like the whole thing. No, not 70%, probably like 60, because we didn't get these correctly. Because it's like 1, 2, 3, 4, 5, 6. So we only did 6. So we only got like 50%. Oh well, but that's usually what comes with learning. Okay. All right. So I think time for a little proofwriting now. It's already like 3. So now let's do the first problem that Sasha assigned to us for the second sheet. Allow, please. Let's make this bigger, like that. Okay, check that Q is a field, and Q and is a totally ordered set. Dang, I forgot what this symbol is. 'Cause I think it's supposed to be greater than, it's supposed to be less than and equal to. I think that's supposed to be a relationship. So now I gotta remember what this is so let's look up the definition of a field, just so that we can be on the same page. So we'll talk on ChatGPT. What is a mathematical field? of f with two binary operations, addition from cross f leads to f. Leads to f, okay. Plus, okay, Euclidean group. Okay. So I think we can copy this because we need the field axioms. Now, let's see, check that the rational numbers is a field and q in the less than or equal to is a totally ordered set. Okay, so let's see, proof. So we have to prove that closure, that basically the set, so we're going to have to prove every one of these. So it's under closure. Oh yeah, this is supposed to be multiplication, I think, because this one's addition and this one's oops, didn't mean to write that. Oh no. Let's see. Make this a little bit bigger, like that. Okay. All right. So in this part here, so we have to prove it's closure for addition. Then f without the zero set. Okay. Multiplication, close under multiplication. Okay. And the distributive property. Okay. I'll be right back, guys. Just give me 1 second. Okay guys, I'm back. Sorry to keep you guys waiting. Let's see. But we also have to... Oh yeah, I think I might have to look back at my old videos for how we're going to define the relationship of less than or equal to. So basically I have my videos, like I'm going to be watching it from my YouTube channel, so like the audio from the video is going to be muted, so it's just basically focus on like thinking about it. Just sometimes I gotta like look back and see what like we went over like last time, so hey Jose, how's it going? I'm basically just like looking back at like an old stream, basically just helping us understand like this problem here. I muted my browser audio so you can't hear it. But how are things with you, Jose? Okay. So I couldn't find exactly how we define the relationship, but maybe we can look into like the books that I've been reading. Maybe that will give us a better idea. I think we have to define the relation. For these type of question, you need to return to basics. A certain relation is a relation of order. If it's reflexive, implies that X is equal. If it's transitive, it's if every element of it can be ordered by the relation, i.e. we can put the relations between every elements. Yeah. Oh, thank you for the follow, random Junke? Junke1? Thank you for the follow, much appreciated. I'm doing alright. How are you doing today? are you like studying math in university? Do you just like math, or oh, why is that? Like, everything okay? Oh, you're 14. Oh, okay. So you're in high school. I'm sorry that you're not doing too well. Like, what's going on? Like, are you feeling sick, or is it like something got you down? Oh, you have a math exam tomorrow. Like, what math are you learning right now? Hopefully I pronounced your name right too. Like I just read it as random Junke, but I don't know if you want to pronounce it a different way. But I have to learn all what I learned in 2 years. Aww. Just call, random? Okay. That's fine. Yeah, actually, is it a final exam? Because it's like about summertime. Sure. If it can help you a little bit. I'm not an expert, to be honest with you. I'm learning math myself. I'm trying to like learn math proofs right now. Basically, the whole channel is just basically me trying to study math myself. So I'll try my best to see if I can help, and if like anyone in the chat wants to pitch in to help you, then that's also fine. This is a safe place. You can ask your questions, and don't worry about feeling like you're gonna like ask like a silly question, because I don't think there are silly questions, especially if you're trying to do your best to be like good at the material. Yeah, I just can't, I just can't one theme like 20. What do you mean by that? I'm not quite sure. I'm not good in 1 of 20. Oh, okay. So what type of math is it? Is it like algebra, geometry, calculus, pre-calculus? Oh, you're from Switzerland. No, it's okay. It's okay. I know like a majority of like my chat is like people from different countries that English is not their first language. Because I think if you're in high school, you're probably learning like probably like pre-calculus and calculus, or maybe like maybe geometry. Romeo and Juliet love each other. When they feel love, they wave each other from the window and simultaneously set off to cross the 100-meter field that separates them. Currently running towards each other. How long do they have until they meet? How far is the... I translated this from German. Oh, okay. So basically, so you have like two people. So, I guess we can like help you out with this one. So, let me just adjust the chat here. So, we got Romeo and Juliet. I think this, I'll pick another one if you want. I mean, if you need help with this one, like, I don't mind like trying to learn it myself too, actually. It's been a long time since I've done problems like this. They wave to each other from the window and then simultaneously set off. Okay, so between them is like 800 meters, right? Yeah, 800 meters. And the field separates them. Romeo runs at a speed of... So the R for Romeo is... What is it, like 10.5456? I'm guessing that's meters per second or something. And then the velocity for Juliet, that's like 6.545 meters per second. They're currently running towards each other. How long will it take them to meet, and how far is the meeting point from Juliet's house? I mean, is that the way the problem is structured? Because I saw that, because it says like the speed of Romeo is like 10, 45, and 6. I don't know if that's like there's a decimal point or something. Kilometers per hour? Oh, okay. But is the speed for Romeo correct? I usually prefer the SI units. Oh, it's 10 kilometers? Okay. Yeah, because I was like, that's a funny way of writing like the speed. Okay. Now, this looks like a typical algebra problem. So, the thing is that we know that both of them are running I'm guessing this is a constant speed, so they're not accelerating, which means that their speed is not changing. So it's per hour. Typically for me, I would just convert the units to meters per second. So let's do that first. So because it's like 600, it's 800 meters, so it's no point in like doing it in units that don't make sense. So 1 kilometer is 1,000 meters, and 1 hour is second. Okay, then we have to take out our trusty calculator, type that in, and then divide that by, so that's around 2 point, we have, well technically we have like one significant figure. Yeah, we can just make it 3 meters per second. Make it easier. And so we have Juliet, so we can convert Juliet's speed, or velocity I should say. because you need to get it in meters, because we have 800 meters, so it doesn't make sense to keep it in kilometers per hour. The reason why I'm changing it to meters per second is because of like, I think it's because like I'm trying to get used to doing that because of physics. So 1 kilometer, and then 1 hour, 36 seconds, 3600. Yeah, it's been a long time since I've done these. So this one, we have Julie at, so this one is, we'll leave it 3, so meters per second. Yeah, you have to basically do it at the So did you solve your problem, or do you want me to continue? Like, is that the part you were stuck at? Just basically converting the units? I think it's okay. Oh, okay. So do you want me to like complete to continue going on with the problem, or do you think you're good now? Oh, okay. So it seems like you're good. Okay. I guess like today we're just doing a lot of math applications. Okay, let's see what you did for this other problem. Actually, maybe we should have the math chat open, so that way you guys like who are watching this on YouTube can see the problem too. Let's see, English task. So let me see if I can copy this. Oops. Let me just copy this. And I think we're gonna paste it in here. That way you guys can see it. Oh, it's too big. And then I'll just remove the chat so it doesn't block it. And actually, for all you guys at home, well, actually, like, we practically like read the problem out loud, so I have like just one tiny problem. Okay, let's see. A rectangular garden has an area of 60 square meters. If the length is increased by 3 meters and the width is increased by 2 meters, the new area becomes 96 square meters. Question: what are the original dimensions and length of the garden? Okay. So usually with geometry problems, it's good to draw a picture. So like, what is the issue that you're facing? Like, what is the part that gets you stuck? Actually, we can probably draw. Oops, no. So, and we'll do another one. Draw a rectangle. Make it look real nice. And it should be nice because we're using a straight line. There we go. Yeah, so you have a clue to... So you have to do a sketch. So you have to do I mean, it's much easier to do a sketch because it allows you to see it clearly. So we have a rectangular garden that has an area of 60 meters. Okay. So the area is 60 meters squared. Yeah, 60 square meters, right? Because it's two-dimensional. And let's label this so basically we'll just label it X and Y for the length and the width. And if the length is increased by 3 meters and the width is increased by 2 meters, the new area is okay. So we can draw a bigger one. We can draw a bigger rectangle. I know this one doesn't look like it's just as... Oh, no, that's not what I want to do. I know this one is not as... Actually, we should probably just... So, we'll erase that, because I want this to actually look bigger. Oops. So, make it a little bit bigger so that it looks suitable for our problem here. Okay, so now we have basically okay, and its new area is 90 meters. Okay. Oh, 96. Right. Sorry. Yeah, this type of problem, it's like, I think it's more effective to actually draw the picture, because when you draw the picture, it actually shows you, like, how to visualize it. Because visualizing it makes the math a little bit easier to see. So basically, what we know about a rectangle is that it involves length and width equals the area, right? So basically, like, x times y is equal to 60, right? So basically, yeah, so basically with geometry, like, once you know the formulas, you begin to, like, you begin to see, like, patterns. So and this is why you have to learn algebra, like, when you learn geometry, because in this point you have to, like, remember this type of setup. I mean, yeah, to, like, basically substitute, you can do that as well, yeah. Yeah, see, you know what you're doing. So basically, yeah, you can substitute for, like, different variables. So yeah, if you want to turn, like, basically, like, x into, like, y over 60, 60 over y, or if you want to do, like, you know, y is equal to, like, 60 over x, you can do that as well. See, you know what you're doing, random. It's just basically just visual. I think you just basically have to, like, see it. Like, when you see it, and then you know and when you actually, like, I would have to say, like, try to find the formula without having to memorize it. So, like, the way to remember the formula for a rectangle, because for a square it's much easier because it's, like, the same sides. So to get the area of a square, you basically just have to square it. That's the easiest way to remember it. But with, like, a rectangle, since the length and the width are different, basically you have to ask a question. Is like, what would happen if I double one of them, or if I triple one of them? Then basically the rectangle still grows. Oh, no problem. I mean, like, this is, like, the basic stuff I can probably teach. Like, cause, like, I think I've done problems with algebra and geometry, like, a lot. So like I've kind of like gotten used to these type of problems. So, you know, that's the best way I can explain it. I think it's now easy for me to learn. Okay, no problem. I hope that really helps you with your exam. I will tell you my grade. No problem, no problem, no problem. Wish you luck. Take care. Well, that was a little bit reassuring. I mean, yeah, like if you guys ask a math question, it might get my brain moving. That's probably like, it's probably very encouraging that I could at least help someone that's in high school, at least. Because I feel like with all the math that we learn in on the channel, I feel as if like I'm so behind on everything. Like I feel like I don't know that much compared to what you guys know in chat. Okay, so I think we can erase this. So now I actually have to, because like this is a relation between like less than and less than or equal to. And let me just drag this over here. So maybe we should find the definition of a relation. That way we can remember it better. Paste. Yeah, if anyone in chat like basically followed my explanation for Random's question and had a better way to explain it, you can explain it in the chat. That way I'll be like, oh, I learned something that I probably wasn't thinking about before. Because I know you guys are super smart. Let's see, a relation is on a set A is a subset R. Okay, often abbreviated. This... Okay, so that's the definition of a relation. Now, oh, they think they give me an example here. Okay, so this is how to set it up. Like this. Let's see, R is... Okay, yeah, this is the question I want to ask. Like, if asked about if 5 is less than 2, he would see that 5 and 2 does not appear in the relation. The set R, which is subset. Translating the problem into a system was a very good idea. Do you mean like with my explanation, or is that what you meant, Jose? I think that's the way my brain works sometimes, because I actually have to have visuals whenever I'm doing like a math problem. I think because of that, that's why I like to do physics problems, because I love in physics you have to actually draw pictures, so it's actually much easier for you to visualize. But I know with math, it's like if you know the definition and you know the I guess like the way the logical framework of how the definition explains the idea, I think that's basically how visualizing doesn't help when it comes to like mathematical ideas. But it does like, I think like visualizing gives better intuition. I think this is why like some people that are decent at math but they don't really like the abstractness of math, they probably go to physics because it's like it's math but it's more applied and it allows them to like visualize things. But of course with physics you have to acknowledge that there's some math ideas that even though you probably got like what do you call it, like a back, like you have an intuition for it, but then you realize that, oh wait, my intuition is lacking because there are certain definitions or certain scenarios that I never thought of with this type of math idea. Because there's a lot of manipulation in physics that I would never have catch on to until like later, or whenever I see a physics solution I'm like, oh, I didn't know that math idea that much that I thought I did. Let's see, if asked if so, oh, maybe we have to look back here. So oh yeah, because these are order pairs and the relation contains, oh, okay. So in order for it to be equal, that would mean that basically we would have to have a relation where it's like let's say, like, this is how I'm thinking about it in my head, right? So it's like, it's a relation, right? So if we think of less than or equal to as a relation, I would think of it as sort of like A and B. So it's like, you know, if A and B are not equal, then there'd be like that. So basically like A is less than or equal to B. But if A is equal to the other half, then we would have A to A in that sense. Like, this is how I'm visualizing it. And if like we have like B, C, and da 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 da, whatever. Having a good visualization of the concept and ideas behind them, it is always good. Yeah. So the thing of it is that now I have to think about how should I think of this? Because this is kind of technically an infinite type of set. So the ordered pair of A and B, things such as A and B are I don't know if that's the right way to think of it. Let's take a look. It may seem simple-minded at first, but this is the central idea. This definition is general enough to describe not just the relation of set A so the subset maybe I should have included that. And as a subset, rational numbers is a field and is a totally ordered set. Set R's relationship since considered the following. Here we go. The definition of what a relation can be. So, suppose that R is a relation on set A. Relation R is reflective if XRX for every X in A. That is, R is reflective if all of X in A. Okay. Relation R is symmetric if XRY implies that YRX for all X and Y in A. That is, R is symmetric if all of X and all of Y in A implies that basically, okay, transitive. Here we have equivalence relations. And equivalence classes. So we probably have to study up on these like in more depth. We have to check if this is a field first. So the question is, do we have to use ordered pairs with this? The thing is that we have to no order in field proof, just laws. It's kind of funny because now you got me thinking of the phrase Law and Order, which is one of my favorite shows, by the way. The one thing is like now I have to think about how do we prove this. Because I don't think you just write like a plus b is like an element of the rational numbers. I feel like it's like more intricate than that. Unless basically the field is just basically like you just like defining it. It's basically like, oh, the rational numbers are supposed to follow this rule and this rule and this rule, and then basically that sets you up for like setting up the next thing. Like basically you just define it as a field, and then basically you go into the next part, and you're supposed to use the definition of a field to help you solve this part. I mean, that's what I'm thinking that's what we're supposed to do. But it says check that Q is a field. have more time thinking about it the next time. But I think I like this change of pace. Like basically, like we started off with some physics problems in the beginning. Of course, we didn't get them all. Like, you know, like obviously I missed some ones. But you know, it was a good way of just like re-engaging with physics. I think like tomorrow we're gonna get like 4 problems from it. So I'm basically doing all the problems from like my old physics professor's like assignment problems. I didn't realize this paper was I didn't realize I still had like the homework sheets until like I actually looked in my old physics textbook, and I was like, oh, like my classmates send me all the papers for all the homework assignments for like the course, like both physics 1 and 2, and I'm like, maybe I should try it. Maybe I should try them on stream for you guys, because like the thing of it is that like I think with studying physics on your own, you're like kind of paralyzed on like what problems to do because there's so many. But because this is like from my old professor's problem sets, I feel as if, okay, this will probably lead us in the direction that we need to do for physics. So thought I would do those with you guys on stream along with doing math proofs. It's very huge and long. If you really want to prove a thing correctly, you can just say to go faster, because everything is trivial using the usual plus and dot. Oh, okay. So basically, I'm guessing what you're saying, Jose, is basically just define the rational numbers Q as a field and basically just list these things out, right? That's basically what you're saying, right? Just basically write down the list in the proof and then basically use the definition and the definition of a field to basically get us to our second part, which is here, which is basically Q and less than or equal to is totally an ordered set, right? That's what I'm guessing you're trying to tell me from what you typed in the chat. But yeah, thank you guys for joining me today. For all those in the chat, thank you for joining me. For all those that are watching this on YouTube, thank you for watching the video. It's always great to basically have you guys like interact with like the videos, even though you're just probably watching it for like maybe a couple of minutes. And hopefully it helps you get something productive like studying, or like maybe something you have to do with your computer or something. Because like I like it when I help you guys be productive, because like being on this, like basically doing the stream, I feel as if like I'm actually being more productive doing math and physics with you guys. So you guys are like also helping me get to my goal of basically just learning more math and physics. So for my Twitch chat, I will put in my YouTube channel if you want to subscribe to my YouTube channel. And for anyone watching this on YouTube, my Twitch link will be in the description down below, including my Discord server, which is the MathSpellBook library Discord. So you can basically check that out. Hopefully we'll be able to like meet there and like talk more about math and physics there. In addition, for my Twitch chat, I will, and my YouTube channel, the link to my video game channel is also in the chat / description down below, if you want to check out my video game channel. Tonight I will be streaming on that channel. It will be a podcast episode, because I didn't get to do a podcast episode last Monday, because we usually do it on the second Monday. So hopefully you guys will be able to attend that if you're able to. Okay, I think that will do it for today's stream. Let's see what we... Well, Jose, you typed something else. Yeah, because it's kind of trivial. You can use its usual plus and multiplication as an argument. Not very incredible. How do you even prove that a plus... Right, very complicated. to prove really correctly from nothing, it's just kind of trivial. Ordering the question is more interesting. Gotcha. Okay, we'll probably like actually I will do myself a favor because I know that's not going to be saved, so we'll probably put Jose's suggestion in the actual, so put it right there, so that way it's a note for us. So I'll just leave that there for like reference, so that way for tomorrow when we actually work on this, we'll probably get to it. It's just a little footnote. Okay guys, thank you for joining me today, and always remember, everyone is precious. You guys are just as precious as everyone else, and I will see you guys tomorrow for the next video, or stream. So take care guys. Bye-bye.